Grainger and Worrall is the world's leading brand in the supply of casting machine parts for high-performance applications.
If making castings and machining castings can ever be seen as sexy, some of our customers is on the sexy side of manufacturing.
Most supercars or hypercars that you might buy will contain parts that Grainger and Worrall have made.
And we are a global business, as Phil probably said. We're 50% export. We've got good business in China, in North America, and around mainland Europe.
This business operates in three discrete ways. One is as an innovator,
which we call the trailblazer business. It's always the one that's trying something new, and it's always developing new product, fast turnaround, flexible approach.
And then of course there's the other side of our business, which is servicing the automotive market at large, where cost is a driver.
In the middle of that is what we call our series business or niche business, what we call low volume production. So this is production volumes between 5,000 and 10,000 units per year.
And that's a tailored kind of thing where we build a little factory for our client. The structure of the business 20 years ago would be more about making to print. It would be more about making what the customer had asked us to make. Now it's more about us working with the customer to arrive at what can be seen to be possible.
The applications of our products are becoming more and more onerous as power and efficiency get targeted by the engine manufacturers or the OEMs, and therefore our process control and our process abilities have got to be constantly evolving.
And our key customers said, look, we want a sustained, robust solution. We need it reliable, we need it robust, and we need it efficient, and all of the good things that automotive would do. So we knew we had to invest, and we committed to 2 years ago a £6 million capital investment into series.
The key drivers we had, environmentally aware, and that we would be looking at reducing energy costs, etc.
There is a huge climate and energy efficiency imperative, so we have to play our part in ensuring that we're using energy efficiently and that we're protecting the environment as best we can.
So the first stage we looked at was improvements within the production of our mould pack, and so we've gone for production machines which are very, very repeatable, very robust, and give a tremendous accuracy and repeatability to each piece of sand.
A sand core is the thing that carries the shape. It is the thing that allows us to solidify the casting in the right way, because it's the media through which the metal solidifies and rejects its heat. It's a hugely important part of the sand casting process. And we can do that very effectively and very quickly, and therefore cost effectively now, with the investments we've made into our core making equipment.
So having been able to make the mould pack that bit quicker, we then needed to be able to cast it. When we came to the casting station, we had used a traditional batch melting process and decided to go for a tower melter to give us the improvements in capacity, but massive improvements in repeatability and health and safety and environmental.
Another example is in the pouring. Pouring liquid metal is an occupational hazard when making a casting, but you have to do it. You have to get it from liquid to solid.
The old manual way of pouring was a bottleneck for us. So the new system allows us to pour, yes, quicker, but I think key to it is the casting we cast at 2 o'clock on a Wednesday morning on an evening shift, night shift, and the one we cast at 2 o'clock in the afternoon on Monday. As many of the parameters that we can control are the same.
Temperature control, time to pour castings, these are complex thermodynamic processes, and they need to be controlled. And where robots can be deployed, they're better than people because they work tirelessly 24/7 and they're very, very reliable. So we've deployed robotics in areas of pouring. It does require a degree of human interface to organise the methods of making castings, but the act of pouring castings is best left to a robot.
We've then moved on to looking at the finishing areas and the actual fettling process and runner and riser removal. and we have gone for an automated CNC robotic machine which has very, very accurate and repeatable operations. And the environmental impact is, because it is an enclosed machine, we have a single point of extraction, so we actually have improved the dust environment significantly compared with using air-driven tools.
The technology is light years on from where it was even 10 years ago, let alone 20 years ago.
We are about future-shaped technology, and every new generation has got some additional technical challenge, faster, lighter, harder working.
Invariably, that will involve them operating at much higher levels of temperature and stress. We can anticipate that, we can join the dots, and therefore we can start to work out where the cliff edges are with material performance, with castability. So that's an engagement, that's a proposition that I can make to my customer when he walks through the door and says, why should I be talking to you?
We have the advantage here that from our prototyping phase through into our production phase, the process is exactly the same. So all information that is gathered by the customer in his initial prototyping stage is repeatable through the whole production.
When the process is delivering a consistent outcome, the designer can design with the expectation that that will be achieved. So you can arrive at a optimized process only when you can believe in the performance of the manufacturing process behind it.
Engine testing and validation is very, very expensive for the customer. So the repeatability of our process and the controls that we put in means that they can optimize and reduce their overall testing and validation, because there is that reliability within the quality of what we're supplying.
Of course, the way it's going with employment law, health and safety and the environment and all of those good things, it ticks those boxes as well. There's less guys touching and getting close to metal.
And therefore we can push the limits of capability with the process, because we can remove certain degrees of safety factors and things like that which are omnipresent when you're dealing with people.
But also, one of the great benefits that comes from all of this is the upskilling of the operator. We're taking the man away from doing routine, monotonous jobs into being much more involved, interacting with the machines, learning about programming and setting up, therefore hopefully making the job more interesting and actually engaging the employee to a greater extent in what we manufacture.
In a lot of industries, and ours is no different, there is this valley of death where people, academics, universities, theorists will come out with some fabulous idea. Policy at governmental levels will be driven by these ideas of getting rid of X, Y, and Z. But somebody has to demonstrate that. Somebody has to upscale it and make it doable. And the market position that we have allows us to do that very well, because we are always on the leading edge through our prototyping activities, and it is very often the motorsport and the supercar industries that challenge the norm, and we are of course a key supplier into that. So we often get first dibs at this kind of emerging technology and challenge. So that is what we are able to provide you, Mr. Customer, if you are saying, why would I want to go working with Grainger and Worrall? It's because we are intrinsically surrounded by the leading edge of casting technology. And we have to resource our facilities to represent that.